20 by 22 and 51 by 22. Now we will try to find the center of mass of a two particle system. So here we have two particles with mass. This is m2 and this is m1. So the center of mass of m2 is c2 and center of mass of m1 is c1. Now we will find the center of mass of this two particle system. So as we have seen that the center of mass is nothing but sigma mi xi by sigma mi. So let's say that the origin of our reference system is at C2, that is this point. So to find the center of mass, first we'll expand this expression, that is m2 into x2 plus m1 into x1 by m1 plus m2. Now x2 is the distance of center of mass of m2 from the origin of our frame of reference. Since the origin of our frame of reference is at C2, so x2 will be 0. So this will be m2 into 0 plus m1 into x1. x1 is the distance of center of mass of m1 from the origin of our frame of reference. Now this distance is nothing but c1 c2 let c1 c2 is equal to L. So we have our center of mass as m1 into L by m1 plus m2. So if this is our center of mass, then the length of C2C, because this length is from the origin of our frame of reference and the origin is at C2, so the C2C would be m1L by m1 plus m2. Also we have seen that the center of mass of a system of particle is at such a point so that the moment of all the masses with respect to that center of mass is 0. So it means that moment of m2 with respect to point C is m2 into C2C, and moment of m1 with respect to point C is m1 into C1C. So the location of center of mass will be such that m2 into C2C is equal to m1 into C1C, because then only the moment of all the masses with respect to center of mass will be 0. Now let's see one more solved example. Suppose there is a circular disk of mass m. The radius of circular disk is r and the center of the disk is at C. Now a hole of radius r by 2 has been punched. So this white portion is the hole and CC dash is r by 2. Now we need to find out the center of mass of the remaining portion of the circular disk, that is center of mass of the shaded region. So to find this, first let's find out the mass of the shaded region. Since the area of entire circle is pi r square and the mass of this entire disk was m, now a hole has been punched off, so the area of this hole would be pi into r by 2 whole square, that is pi r square by 4. So since the mass of pi r square area was m, so the mass of pi r square by 4 area would be m by 4. So the mass of the remaining portion, that is the shaded region, would be m minus m by 4, that is 3m by 4. Now what we'll do is we'll take this circular disk as as being constituted by two parts. One is the shaded region of mass 3m by 4, and one is this hole of mass m by 4. Now the center of mass of this complete disk without any hole will be at C. So now this problem reduces to the following, that is, we have two masses. One is of mass 3m by 4 and the other one is of mass m by 4. This is the center of mass of mass 3m by 4, that is C dash. This is the center of mass of mass m by 4, that is C double dash, and in between there is a center of mass of these two particles. So as we have seen, the location of center of mass would be such that C dash into 3m by 4 will be equal to C double dash into m by 4. Now C double dash is nothing but r by 2, the radius of the hole. So r by 2 into m by 4 will be equal to C dash into 3m by 4. So here we can cancel out m and we can cancel out 4. So C dash is r by 6. So this length is r by 6. So the center of mass of the shaded region would be at a distance r by 6 from the center of the circular disk. Now let's define center of gravity. Center of gravity is a point through which resultant force of gravitational pull always passes, irrespective of the orientation of the object. In the uniform gravitational field, the center of mass and center of gravity of an object always coincides. And as was the case with center of mass, center of gravity of a system of particles can also be defined as the point about which the sum of moment of gravitational forces on all mass particles is 0. So this is all about center of gravity. It is quite similar to the center of mass concept that we have discussed earlier. Now we will see how the center of mass is related with linear momentum. Linear momentum of a mass particle is defined as the product of mass of the particle and its velocity. It is a vector quantity and the direction of momentum is same as the direction of velocity. So we write P is equal to mv. Now linear momentum of a system of mass particle is defined as the vector sum of the linear momenta of all the particles enclosed in the system. So suppose we have a system of particle here. Suppose we have a particle m1, m2 and m3 in the system. The velocity of m1 is v1, that of m2 is v2 and that of m3 is v3. So P system, that is the system which has m1, m2 and m3 as its constituents mass particles. So the P system would be sigma mi vi, which will be equal to m1 v1 plus m2 v2 plus m3 v3. Now let's see what is the center of mass of the system, that is system with these three particles. So the position vector of center of mass would be RC is equal to sigma mi ri by sigma mi. This we have already seen. So if we differentiate this equation, we'll get Vc, that is velocity of center of mass, is equal to sigma mi, and again differentiating Ri, will get Vi by sigma mi. So sigma mi Vi is nothing but P system. So Vc is equal to P system by sigma mi, or P system is equal to Vc into sigma mi. So from this equation, that is P system is equal to Vc into sigma mi, it is clear that the linear momentum of a system of particle is equal to the velocity of the center of mass of that system into the sum of all the masses. So P system would be equal to Vc, that is velocity of center of mass, into sigma mi, that is m1 plus m2 plus m3. So if we know the velocity of the center of mass, then we can predict the linear momentum of the system even if we don't know the individual velocity vectors, that is v1, v2 and v3. So even if we don't know the value of v1, v2 and v3, but we know the value of vc, that is velocity of center of mass, then we can find out the linear momentum from this equation. There is one more thing. A frame of reference attached to the center of mass of a system of particles is called C frame. So if the origin of the frame of reference is at the center of mass in a system of particles, then that frame of reference will be called C. Now we will start the chapter Newton's law. Newton has given us 3 laws of motion, which we will discuss one by one. So we will start with Newton's second law. Newton's second law defines the force as rate of change of momentum. This law is also called the fundamental law of dynamics. So according to this law, the rate of change of momentum of a system is directly proportional to external forces applied to the system. So here, as you can see, that F external, that is external forces applied to the system, is directly proportional to the rate of change of momentum, that is dp system by dt. So here P system is momentum of the system. In the SI unit system, we choose the unit of force in such a way that the proportionality constant becomes 1. So F external will be equal to dp system by dt. So this is true for SI unit system. So continuing the discussion further, we know that the momentum of a system is defined as sigma m into Vc, where sigma m is the total mass of the system and Vc is velocity of the center of mass of the system. And sigma m is the total mass. So let's talk about a system with constant mass. So according to the Newton's second law, the external force applied on it will be equal to dp system by dt. So P system is sigma m into Vc. So F external would be derivative of